you point here, the right. Okay. May I start? Can boa tarde a todos e a todas. Vou só fazer a apresentação. Então, okay. Okay, it's ready now. Thank you very much to be here. We are very close to the end of the year, the academic year. I know it's a very big effort for all of us to come here. But it's a pleasure because we have this opportunity to have my colleague, Professor Olivia Levrini, and in the following up, my colleague Lorenzo Miani, that have the two very good presentations for us about a project. And just I'd like to introduce Professor Olivia Levrini. Professor Olivia Levrini is a full professor at the University Department of Physics and Astronomy at the University of Bologna. She is also a coordinator with me with one of the special interest group at ESERA conference. ESERA group. She also organized the ESERA meeting in 2019 in Bologna. And she's also a very coordinated a big number of projects, European projects. And one of them is the subject, the theme of today. It's Fedora, and didn't highlight more. I will leave the place for Olivia to explain. But if she's developing a very interesting research activity now, is the connection about the future studies and science education, and with a very important impact in the kind of the contemporary situations that we are living now, involving the social accelerations, the questions about time and others. Okay, it's a very good pleasure to have she here, and I would like you enjoy the seminar. Okay, Olivia, it's up to you. Thank you to be here.
Thank you very much. Can you hear? Can you hear? Okay. So thank you very much, Mauricio, for the invitation. Thank you very much for the presentation, and it's an incredible opportunity for me and Lorenzo to be here, to know so many interesting people, and also to be immersed in this culture and in this atmosphere that is somehow close, but also some different to ours. So it is nice to see and to share these ideas and to collect it. This is what my dream, to see the reaction and to see your thoughts about the perspective that we are trying to develop in Europe, and in particular in the Department of Physics and Astronomy of the University of Bologna, where we come from, and where we are developing this futures-oriented science education model, a way to, we use this word, to futurize science education in order to make science education a place, a context where also we can guide our students to develop capacity to imagine the futures and to act in the present with an eye on the horizon. This is how we mean by futurizing science education. So we are not talking about the future of science education, but how to use science education as a place to develop capacity to imagine other futures, other possible futures to the one that now we are obliged somehow to follow, that is not so nice as so nice. So this is my third presentation here in São Paulo in the last 2 weeks. So I'm sorry for the people who already attended my other talk. Enrico, sorry for that. I tried to take another angle. The first one was much more political, the one of last week. Yesterday, we discussed with some of you about the emotional, also the perceptive aspects of futures and how future touches emotional aspects, and to Today, I tried to follow another angle that is much more epistemological. So what does it mean to think about futures-oriented science education from an epistemological perspective? So from a physics mainly education point of view. So the starting point is always the same, because this is, I don't know why it did. Sorry. So this is always the starting point, because this was the encounter with this book and with this author was really the very first motivation for the project Fedora that I will talking about. And this is the book of a sociologist of time, who is called Hartmut Rosa, who is very influential in Europe. He's German, but he's very influential in Europe because he is trying to produce a picture, an analysis of our society from the perspective of time and from the perspective of acceleration. This is a book where indeed he tried to organize a sense of discomfort that we are encountering in our society in terms of future shock due to this acceleration of our society. We started indeed with this idea because our students in our classes actually were manifesting a sense of discomfort with the perception of the future. And we found that it was not something personal, but it was really a manifestation of something that was happening at societal level. Because indeed, as Hartmut Rosa says, we are in this moment where the acceleration of the society due to the technological acceleration is so huge that the rate of change is much faster in the society than the capacity to interpret and the capacity to analyze what is changing. So we are in a society where the social acceleration is, and the velocity of the change is much higher with respect to our educational system and our capacity to interpret what is happening. So this future shock implies that the perception of time in our society is completely different from decades ago. And this is very strongly perceived in the young generation in the sense that in this period, the point is that the society is changing so much that it's very difficult to imagine and to project the imagination in the future and to see a possible futures. But if you don't have an horizon in the future, if you don't have what we called a life plan, something like that, a project, a life project, also the action in the present become problematic because you have the experience of many different events that are all the same, and you don't have strong criteria to establish what is more important than other for your personal life. This is what is called actually a fragmentation of the present, and also because of this fast change, also the past and the history is in countries not easy to find in the history in the past some ideas or some keys to interpret what is happening now. This is what we discussed also yesterday with the group of the PhD students, because this is in the Hartmut Rosa book, but I think it is very interesting to see and to have the perception of what present is perceived by using these two words that are two German words that indicate two different ways to describe events in the present. The first one is Erlebnissen. This is a word that is used to describe episodes that happens in the present, but they are just mere episodes of experience. It's just something that happened, but it's something that doesn't have any implications in your life. It doesn't leave traces in your personal life. Instead, Erfahrungen are instead this moment, the episode that instead maybe they can appear and happen in a very quick way, very quickly, but they become long in your perception because they are events and episodes that are important in the formation of your identity, in your personal life. So the point that Walter Benjamin, this intellectual at the beginning of 20th century, 1 century ago, said that the crisis of the beginning of the 20th century was characterized by other changes, and in particular, he complained that 1 century ago, it was characterized by an era where there were many Erlebnissen, so just events, and few Erfahrungen, few moments that are epiphany, that are the moment that give sense for your life. What Rosa says that today, because of the acceleration of the society, because of the rhythm of our life, so frenetic, leaves all of us to reason a moment where we have many episodes in the present, so many stuff, and we are not able, we don't have the time to give sense and to take care of what is happening in order to transform and to recognize in our events what is important for our society, so for our personal life. This is what Rosa called moment of short episode. They appear very quickly, and also they leave short traces in the memory. This is what also yesterday discussed. What I would love to stress today, following this reasoning, is that because of for science, and in particular for science education and for physics education, the society of acceleration is a challenge because actually is somehow challenging a myth of the progress and the sense of direction and the sense of the future was much better than the present. That was actually the roots of our modernity project, the root of the scientific project that characterized the enlightening and the previous era. So now we are in a moment where, because of the acceleration of the society and the fact that the future becomes invisible and opaque, challenges the sense of the progress and the trust, the trust in the capacity of science to create a better and better future, because we are aware that now also the society, the acceleration and the capacity of producing new technologies of our society produce important things, but also there are implications and there are consequences that are challenging our society. So they don't go in the direction of a better future. So the acceleration is touching the very foundational epistemological pillars of the myth, also of our scientific project. And this is a point that for us, we are physics education researchers, is something that is important because we experience in the society that now there is a moment where science and technology are not something that all the people trust in the same way that we experienced in the past. And this is also just to finish this introduction, also what is this society is creating. This is following Armut Rosa thought, this sense of alienation because of this acceleration also makes us to feel the time as something that is not related to our inner pace, our inner temporal needs, but it is something that is external, controlled by external factors, external forces, that is detached from personal needs and meaning. And this creates also an alienation from the self and alienation from the others, because also the sense of the self, the sense of the identity, and is due to how we organize our personal experience and our relations with the other in a space-time fabric. So the kind of we organize time is strongly influenced also by how the society organized. This is producing, we discussed yesterday about this sense of problematic burnout among teachers and students, a problem of disconnection of the learning activities and intrinsic motivation and fragmentation of personality. But today, this is the main point of today. I would love to discuss how and why this, one of the other implications of this acceleration and alienation also, that another implication that concern the knowledge. Another catastrophe, in some sense, of the acceleration is the problem of the fragmentation of knowledge. We are in this moment where the production of information, the production of data, the production of data and information is bigger and bigger. And actually, this is something that is that our students experience, because in order to turn data and information into knowledge, to turn knowledge into wisdom, into Sophia, into something that makes sense to you, and to turn knowledge into something that not only makes sense to you, but into something that also can orient you to take agency, is a process of working data and information that takes time. It's something that is not quick. It's a way, and in this sense, we are in a moment where the main virtues, I would say, that our school system was supposed to develop, capacity of thinking competencies, capacity of processing information, of elaborating information, that are in our culture comes from Aristotle, the dianoetic virtues, that are to take episteme is one of these skills, good thinking skills. Episteme was the capacity, the ability to turn information into an organized, reliable knowledge, and to recognize and to proceed and appropriate scientific epistemic practice like modeling, argumentation, explanation. This is episteme, in this, to turn information into knowledge in order to be able to control them, take care of this. But also the nous. Nous is in the Greek culture, in ancient Greek culture, was the ability to nurture intuition, the creativity, to grasp the moment and to elaborate the intuition. And then there is this other ability that is Sophia, wisdom, the ability of sense-making, take knowledge and to recognize a meaning, a sense for you, an existential meaning, not just a school activity, not just a school performance, but to use knowledge in order to turn that into something that makes sense to you as a person, as a citizen, as a part of a collectivity. And also phronesis. Phronesis is another of these abilities of Aristotle about the ability of turn knowledge into a reliable reference for making decision. We call this agency. In the ancient Greek, it was called phronesis, the capacity to take action and to turn knowledge into something that can change. So all these abilities, I mean, they were the basis of our school system. School system were supposed to create this kind of ability, but instead also in our school system, the rituals in our school system, the rituals in our university are strongly influenced by the velocity, the acceleration of our society. And also to develop this kind of capacity, this kind of skills is becoming more and more problematic. And this is why in our schools and also in our university, I come from the Department of Physics, so my students are physics students of the bachelor and the master students. Not always, very often, express a sort of discomfort related to knowledge, because the knowledge and the information that we provide them is something that is losing a sense of life, is losing a sense of capacity to interpret the world. And this is what I started to perceive in the discussion with my students. Many students come to me and to say, I'm in a moment, I love physics, but I have this problem that in this course, in this learning path, I have this problem. Someone complains a sense of claustrophobia, that is a sense of a silos effect, in the sense that they felt to be guided into a more and more specialized knowledge, more and more technical, that is very important, but it somehow guide them far from the complexity of the world. This is one effect, the silos effect. Other students, or in another sense, instead complain the fog effect, in the sense that they complain a sense of agoraphia in the society. They feel a sense of anxiety because they don't know how to use the knowledge that they have in order to get oriented in the complexity of the not to see that. This is something that is very interesting but very sad in our group, because the number of these students, I mean, is not. I mean, there are these students that have this epistemological crisis in some moment. In encountering physics, they have this epistemological crisis in some moment of their path. And indeed, there are. We organized a group of students that we called the Gruppo Fratture, the fractures group, because they express this sense of a fragmentation of their identity, because they identity as physics students becomes different from their identity as people living in the complexity of this world. And and this is also something that is at the beginning, at the very root of our Fedora project and Fedora project, because it is everything related to the society of acceleration and related to this difficulty to see the future and to imagine the future. And this sense of the crisis of the knowledge is very well described in this book by Amitav Ghosh. He's a writer, he's a novel writer, an Indian novel writer who lives in US now, but he described this challenge and this crisis due to the quick change also of climate. The climate change and this change and environmental level, but I would say also we are in a democratic crisis, in a societal crisis, in a technological transformation. So all of these big changes are really challenges our culture. Yesterday also I mentioned this writer. He is an Icelandic writer, and he'd say that express the problem of our knowledge, our capacity to name what is happening by describing this language crisis. He says, how do you talk about something that is bigger than language? He's talking about climate change. He says it is bigger than language. What words do you choose when a scientist shows you how everything will change in the next 100 years? How the glaciers will vanish, how become ocean, how the ocean will rise in shallow coastal areas, while the pH of the oceans, the acidity will change more in that it has in the previous 50 million years. How do we understand 50 million years? How do we understand that 0.3 in the logarithm scale of the pH levels, 50 million here are too big to register. 0.3 in pH are too small and abstract. A person born today can measure in his lifetime greater changes in the oceans than not only the whole evolution of man, but 10 times that. Such change is not just historical. You could say it is mythological. It is touching all the foundational myths of our society, in our relationship with the nature, and how we perceive the relationship between the change in a society, the social, personal change with respect to the change in the nature, the geological change in the nature. So, we are in this moment also where the society of acceleration is challenging our knowledge system, our culture, our knowledge system. And so the the point is, now we are in front of this. For someone, it appears as a sort of sense of abyss, a sense of primordial chaos, a moment of big transformation. How can we deal with this? What is the feeling, the attitude with it? It can be typically when the changes are so big, the reactions can be of different kind. It can create a big fear. This is something that happens with the young generation, a strong sense of fear, of anxiety. It can be also a sense of wonder, the sense of maybe it is the moment to search for other alternatives, because maybe to search for other possibilities, for other way to live together with the nature, to get together and to imagine our society. So, that was our question in front of this. What is our role as physics teachers, as science education researchers? What is our role? And this, we started to think about how to approach this big changes, how to attack, how to enter, how to frame these problems. This was an image that Francesca, a person of our in our group, suggested. And instead, this is a Brazilian book for children that Cristiano gave me just because of this idea that in front of such big change, actually the first temptation is to try to get stuck and to try to stop and to save what can be saved, because it gives you a sense of security, a sense of comfort. This is what the first temptation, but like an equilibrista, like instead as an tightrope walker, Philippe Petit was one of the most important tightrope walker, and he said that when the wire shakes, when you see that there is some change, that the wire shakes, one wants to firstly impose calm on it, just to try to focus on it, but instead one must move with gentleness, without disturbing the song of the rope. One must not strive to stand still, but just to gain ground, just to go and to try to follow and to follow the change and to follow the rope. So that was a sense of inspiration also to try to find a sort of attitude toward the change and toward the transformation. This was also a very important book for us. Bernard Sayag, he is an Argentinian psychologist and also philosopher. Now he lives in France. But it is important because in this moment, what he tries to stress is the important that within the chaos, in the chaos we live in, it's important for the young people to glimpse alternative possibilities for the existence, to understand that the world that have been left as a legacy contains new possibilities to explore, just to try to adopt an ethic of the possibilities, not just to get this was an inspiration in order to try to change the attitude from the sense of the tunnel effect, the silos effect, and the sense that we are going into something that is closer and closer, instead try to search in the present, in the complexity of our reality, new possibilities, new possibilities for the future. This is also a quote from an Italian writer, Italo Calvino, who is one of the most important writers in Italy. And he said that this is a sort of also political manifesto. He said, the inferno of the living is not something that will be. If there is one, it is what is already here, the inferno where we live every day, that we form by being together. There are two ways to escape suffering it. The first is easy for many. Accept the inferno and become such a part of it that you cannot longer see it. The second is risky and demands constant vigilance and apprehension. Seek and learn to recognize who and what in the midst of the inferno are not inferno, and take them, endure, give them space. I'm also very keen on this picture because this is an artistic installation of a friends of us from Bologna. They said it is called What is Not Inferno, the poster that was put in the center of Beirut, just just to try to give this message, to seek and to search as an attitude to give. And I don't know if I'm right, but I will encounter, and I think that also this is the sense that I gave reading reading Krenak and reading this to try, because the apocalypse, this is what I got reading this perspective. The sense of apocalypse is not a science fiction, is not, but it's something that some culture already experienced, the end of one word. So what are we talking here? The change of not the word, but one word, one out of many possible words. So the ethic of the possibilities that for us comes from Appadurai to Amitav Ghosh and also moving. I think that this is a sort of synergies among our culture, because it gives this to search in the complexity of the world, what can give a new sense, a new perspective to and but what about science? Because what about science and what about education? Actually, for me, I love the history of physics. Our research field is physics education and history of physics. The history of physics is characterized by changes of the paradigm. In the history of physics, we experienced many changes in the big picture of the world. Really, in the changes of the paradigm. This is the Copernican revolution. I mean, we in the telescope of Galileo, when he pointed to the moon, he discovered that the moon is made by Montas, made by third. I mean, that was a moment where the sense of epistemology, not only epistemological, also social, theological, the symbolic world that existed immediately break down. It was all the world that was challenged, because the thelematic system was not just a way to describe the nature, it was a way to make sense collectively. It's a semiotic, it's a framework to make sense of the life. So also science passed through very deep radical change. Now we are celebrating the International Year of Quantum Science and Technologies, because actually 10 years ago, the matrix, the mechanics emerged. There were the paper by Heisenberg, Born, and Jordan, who changed completely the way to describe a process. We was used to follow the process in the evolution in terms of time equation. Instead, here they introduced a different way to describe a process through matrix, to follow this initial state, the final state, and to see how the transformation and the transition from one state to another state could be described through a completely different mathematical model. The matrix is not a time equation. So science is in his history encountering a lot of changes and elaborated also new languages to describe changes, to describe the evolution. It is also very interesting to see that when quantum mechanics was established, the physicists had also to discuss about the difficulties of natural language, of our language, to name what was happening. It was another linguistic language crisis. Bohr said that indeed we don't have the words to describe what happened at quantum level. But because the quantum world works in a different way, with different dynamics with respect to the ordinary phenomena in our space-time scale. So classical mechanics spoke a language that was the language of quantum physics. And he used this expression, we are suspended in language our language is not able to capture, our natural language is not able to capture what happened at the quantum level. So science is rich of prizes in the foundations to find new a way to the history of science can be seen as an evolution of knowledge. This is an amazing book, I think, by Jürgen Rehn. Jürgen Rehn is the president, the director of the Max Planck Institute of History of Physics in Berlin. And he wrote this book that is the history of knowledge. So it's an epistemological history that describe how our epistemological paradigms changed and why also we are in a moment, the Anthropocene of Capitalocene would say that we are in a moment where we need to find new language, a new symbolic system to interpret what is happening now. But this, I think, is the positive news. I think in all this story, I mean, this is our bet. This is our, from our perspective, I still repeat, our perspective is the perspective of people who live in a physics department, who try to teach physics and to use physics as a way to provide the knowledge to make sense of what happens, try to happens out of the physics classes, both at secondary school level and also at university school level. So the good news for the physics perspective is that indeed physics has elaborated an amazing area of knowledge, the science of complex system, the physics of complex systems, that has mathematical models, that has tools, that has a language, that has an epistemology, reflection on it, that is today much more powerful than the Newtonian mechanics that was used to represent a world that doesn't exist anymore in some sense. And indeed, it's not by chance that the science for Italy, this is also we are very proud because we had the Nobel Prize for the science of complex system that is used within the climatology. So that was a very big, important moment for our community and also for so, and Giorgio Parisi is really a physicist who is strongly also committed in really creating a just world and to use science and physics also for political reason to try to democratize and to try to use this knowledge in order to create a better world. So it's not by and it's not by chance that the science of complex systems since the 80s actually was used also at the basis as a sort of educational paradigm, also something in order to create a new way, a new pedagogy. This is Edgar Morin from France who wrote 7 complex lessons who used the science of complex system to redefine the pedagogy. Just a moment. Yes. So, okay. No. I thought I was already run out of time. So the epistemology of complexity was already used in the 80s also as a way to rethink about the pedagogy because it is a nice source of thinking of virtutia dianoetics virtus way of thinking that were already supposed to be particularly important for our society. And also the Gregory Bateson used this also for his work. because actually the idea is not just to use our physics and science classes to try to pursue and to try to give, as we did in the past, only a sense of certainties, because science, of course, this is also science. Science was built in order, science and math in particular, was built in order to try to give certainties, to try to recognize the robust knowledge, so robust knowledge that we consider it true, we consider it able to survive to some contingencies. So the mission and the tendency to the certainty and the true is part of the mission of the vision of science, of physics and mathematics. But however, in this moment, we are in a moment where we need to combine the need of certainties, but also the necessity to deal with unreducible uncertainties that also enter in physics, enter in science through the uncertainty principles, because of the probabilistic uncertainty, because of the statistics, because of the science of complex system that has some uncertainty that cannot be eliminated. They can be reduced, they can be studied, they can be managed, but uncertainty and the randomness genuinely entered the science through quantum physics and through the society. So in this moment, we are in this sort of pedagogical mission that is important to keep together this tension between the need to search something certain, but also the necessity to deal with, to dance with forms of uncertainty. So in Fedora, this is what we tried to do. Also we discussed also yesterday about this, to analyze our curriculum, to think about our physics curriculum, to think about the knowledge that are part of our syllabus, and to see where and how we can find the room to discuss about certainty, uncertainties, future time model, models of change, the nature of the changes that is described in the physics as in physics as, and that will become the sort of goal for our courses, not only to teach Newtonian physics. Of course, this is the main area that in our school teach. But this is very important also because Newtonian physics really was the pillar of the modernity project. Really, the way of thinking, Newtonian, Laplacian way of thinking is part of our mindset. But physics is not only that. This is important, but this is not only Newtonian physics. Also, quantum physics elaborated new model to deal with change and time evolution, and the science of complex systems. So our goal was to use this content and to make a sort of elaboration, start from them, in order to develop capacity, a new vocabulary, a new way to talk about the future and change, and to introduce the concept of uncertainties, space of possibilities, future scenarios, projection instead of deterministic prediction, feedback, and circular causality, that are all words of the science of complex systems, in order to build, that was our metaphor, future scaffolding skills, ability to create a scaffolding that you can use in order to put your imagination, to change the perspective and to see the future from a different perspective, and not immersed in the reality where we are. To build something in order to be free and to be able to see something in the future, and to empower action in the present, but with an eye on the horizon. And for us, it was very nice to we discovered, that was something that we learned already something like 10 years ago, that indeed the science of complex systems is the epistemological paradigm, the epistemological basis of future studies. The future studies as we consider them now, is an interdisciplinary field. This is an area, future studies, where they study the futures, plural. And it was established in the 60s, 70s of the last century. It was very interdisciplinary, and the goal was really to use also scientific tools like the simulations, the Monte Carlo simulation, and the simulation that were creating in physics and science, and also in the science of complex systems, to try to create tools to imagine possible scenarios and to create possibility to explore alternatives to the main, to the only one or the most probable future. And so that was they were established in the 60s and in the 70s. So, and this is, we discussed also yesterday about this. So sorry, Enrico, for the third time that you listened to, sorry for you, and I cannot skip it. It's always everything leads to the cone. And because this is really the main aspects of the future studies. I mean, and the idea that it is an ontological shift from the previous study of the future, because in the earlier studies of the future that were called futurology, it was a way to study the past and the present in order to discover some laws, okay, also in the social dynamics, also in the political and social and economical dynamics. The idea was that also the social aspects and economical aspects followed deterministic laws exactly as a mechanical object in physics. So it was possible to read and to investigate this phenomena in order to discover the laws for the future and to make plan for the future. That was really a particular plan that was established after the Second World War in US. It was built an organization under the Department of Defense in order to try to make the plan in order to win the Cold War. Okay, so to find the strategy to win the Cold War. And instead, the future studies were established as a sort of reaction against this idea of a unique future. And it is based on this ontological shift. The future is ontological, not unique. There is not one future, but there are different possible futures, as actually different past, different history, different way to recognize and to read the history and the past. But also we are talking now about the future, different, to expand the possibility of the future and to recognize that even if there is what they call the probable future, that is the projection of the main trends from the present to the future, but however, it is possible to conceive also plausible futures, alternative futures that can happen if something that maybe some events maybe are not so probable, but if they happen, they can create a completely different future. So these are the plausible future, but on in the cone of the futures, there are also the desirable future. Desirable future are different from the others. Also, they are different because these are supposed to activate collective form of reasoning, collective form of discussion, to frame the discussion in a different way, because desirable future implies that we don't move from the past to the present to the future, but we imagine desirable future through an action, imaginative action, through imagination. And the imagination is something that can do that foresight, put the imagination forward, or anticipation, just to imagine other possibilities, just to imagine other possibilities, and to do then, after this, a process of back discussing. As soon as you have shared values, hopes, desires, and values like that, to go in the present and to try to make actions to maximize the possibility, the probability that desirable future can be realized. It's a sort of new utopian view, utopian that, however, are supposed to be shared, desirable alternative future that, however, can be pursued through actions also in the present, through what they call action competence. And this is the basis, this cones, based on the science of complex system and of the ethics of possibilities, I would say. This is also what orients that orients this idea of teaching the future, because to teach the future sounds strange. Seems one to have the crystal ball to imagine the future. This is not what happens. Yeah? To teach the future means to create an attitude, to create a knowledge in order to wonder and to ask specific questions and to try to deal with questions. For example, the question of not only to teach and to predict what will happen, but also to anticipate what could happen and to ask what could happen, not only what will happen, but what could happen, and activate reasonings in terms of what if, that is strategic thinking. What if, in addition to what is and what was, and also to teach to imagine alternatives, many possible, plausible, desirable futures. And also to teach to manage contingents and to think contingent, to think that something can happen, to try to imagine what happened and to how to manage contingencies, also risk. But also, this is very, very important for this approach, not only to think the future, but to link thinking and action. This is this combination, this tension between thinking the future in order to act in the present with an eyes on the horizon. So describing alternative futures and empowering students to influence them is somehow the motto of Teach the Future from the Future Studies perspective. This is somehow the main, and this is what we tried to do in our project and in the design of teaching modules for secondary school students, starting from science. This is a structure, a typical structure of our module that was used to design modules on climate change, but also on quantum technologies, artificial intelligence, and also simulations of complex systems, simulation and agent-based simulation and equation-based simulation. That was another topic that we taught. These modules were designed at the beginning, at the very beginning. They were designed not to be implemented directly in school, in the school curriculum, not directly in the school curriculum. That these were used to be implemented in curricular, but not curricular activities, but not in the morning official, because curricular also they foreseen extra activities that has to be carried out in collaboration with university, in collaboration to others. So they are part of the curriculum, but not of the syllabus that we conceived in the morning. Okay, so they were afternoon activities that was typically chosen by students already interested in science, because these kind of activities had also the function to orient students to. But you know, when you talk about climate change or artificial intelligence, many different students come because this is really transversal. This is not something. So they were modules developed in the physics department and offered by the physics department, but we had students science oriented, but however, a rather different kind of. So this is the structure. After an introduction, this was the core of the scientific activities, where the concept of climate change, the greenhouse effect, for example, lab about the greenhouse effect were done, and or in the quantum technologies, the foundations, the basic idea of quantum physics, superposition, the concept of quantum state, superposition principle, what is the measure in quantum physics, what is entanglement, with just the basic, with a very minimal formalism. But then that was, it seems very minimal here, but that was the most important point, because here it was the way where we created activities that we called epistemological activities, activities that were used to reflect about the models that we implemented in quantum physics, in climate change, in artificial intelligence, in order to see that behind there is not a Laplacian deterministic model, but also that in all of these fields, we were using complexity as an epistemological paradigm, and we were discussing over knowledge that has different values, different epistemic values, and different concept of what does it mean to model a system, to frame a problem, to deal with the to deal with the uncertainties. So these were activities that were almost the same in all the modules. And then after that, we had the activities that were much more, they were activities that were much more focused on developing future thinking. So they were lab activities where we implemented sort of future workshop to guide the students to make their desirable future, to imagine a problem, and to imagine a future where this problem were not present, and to imagine possible action, collective action to deal with the problem. Okay, so these were activities inspired by the future studies. Okay, some much more, a little bit. Do you have questions so far or comments? Just to stop a little bit because I'm talking a lot. Yes? Sorry. So maybe before moving to the implementation, just.
Hello. Hi, my name is Emma. My pronouns are she, her, and I have a question. More louder?
Yes, please.
Okay, my name is Emma, and my pronouns are she, her, and I have a question. If you don't understand very well, I can ask to teacher Maurice to translate to me. But you think that the basis of Newton physics is also the Aristotle thesis of matter and nature, and the change that we speak today for science education maybe is more inside of Plato's thesis about nature as Aristotle, because Plato and the theory of Plato about nature says that we have form, the nature have a potential indeterminate to choose form, and after choose form, we have the essence. And that is the uncertainty principle of we have discussed right now. So maybe Plato was right and not Aristotle. So in that way, we have to teach in Plato more than Aristotle or something like that. You understand?
I think so. I think so. This is a very interesting, very deep question. I don't know if we need to teach more or less or Plato of Aristotle. Yeah, probably yes, The point I think actually that behind the Newtonian mechanics and paradigm, I think that there are some assumptions that are also in the coming from.
Louder, louder, more louder.
Can you hear better now?
Yes.
Okay, so I think that probably in the I would say that in the Newtonian paradigm there is the Cartesian view behind that. That was really, as you said already, the detachment between mind and nature, between the science of the spirit and the science of nature, and the possibility to make a demarcation line between subject and object, and to recognize nature as an object, something that is there, that is ontological given, that is something that is, you just have to discover the laws of nature without interacting, because it was possible not to interact in that assumption, in this distinction between, and that was really all the positivistic paradigm that was there behind that, and all our methodology, our mindset is built on this dichotomies: nature, humans, mind, and body, and also subject, object. This is a binary always, a binary, a detachment way of framing the problem. It was incredibly fruitful. It was incredibly fruitful, and it was able to create this knowledge, covering that nature is reacting. We are not out of, it's not this detachment, we are not out of the system. We cannot consider nature as something that is out of ourselves. We are in the Western cultures, we are reconsidering. So probably instead of going back to Plato and Aristotle, maybe we need to expand the perspective all over in the world, and to reconsider the cultures that had other paradigm in this complex interaction between in a, I don't know if I answered.
You ask, I agree with that. Thank you.
May I continue with this one? And indeed, in the science of complex system also is a sort of translation into a scientific paradigm, a scientific model also of this impossibility to detach the parts of a system with the behavior of a system, and challenges this dichotomies in some way, and reconsider and reopen the debate and the discussion about this detachment. So this is the now in the core of all of our presentation, as I already stressed, there is this perspective of complexity. Now, actually, I don't talk about activities that have been built in the Department of Physics as afternoon activities, but implementation that were directly realized by teachers in their classroom and in the classes within the regular physics, and not only physics, but also literature course, because it was an interdisciplinary project that used the science of complexity also as a sort of boundary object, a sort of interdisciplinary object to see how the different disciplines, so not only physics, but also chemistry, philosophy, literature, history, to reconsider, because time and future and the complexity can be a boundary object of all these disciplines. So this is a project that was built for introducing this new way of thinking in the actual classes. And there were different projects within Fedora, within another project was called Climademy, and now within Fedoras. I mean, there are activities within this European project. The first one was called Kairos, a way to talk about time, the contingencies, the moment of that can make the change in the perspective and in the evolution, and the other is called Salomon. These were projects. It was very nice. It was very interesting, because also from a institutional point of view, because the first project was carried out in 2022 and 2024, and it was a sort of pilot activity carried out within Fedora by these teachers in one class, just one class, of grade 10, means 15, 17, 16 years old students with two teachers, the physics teacher and the literature teachers. The year after, it was a project that involves 5 classes. 5 classes meant a lot, 17 teachers collaborating in this one, because 5 classes, all the class had all the teachers in. So it was a moment where really from one good practice, it became part of the, we say, institutional culture. It was somehow institutionalized. It's a delicate process, not so stable, but it was a very important activities. And also with the involvement of the vice principal, that was also very important. For us, the main, the core activity were the activities on the science of complex systems. Okay, so these are the 3 activities that were carried out by the physics and the chemistry teacher. The first one was a way to introduce the word of complexity, playing with net logo simulation. I don't know if you have familiarity of that, but then there is the Bernard style lab activities, and also another chemistry lab activities with the oscillating chemical systems. Just to give you a this, if you today the website have some problems, but this is you can download the activities. Some of them are, no, all of them are within a platform in a project that is called Climademy. That was a sister of Fedora and Fedoras, but if you are interested and you need to register in this platform, but they are available, these activities. Just to give you the sense of what the teachers carried out and taught in these activities. The first one was the word of science of complex systems. The teachers try to make sense and to use these words and to introduce the sense of what is an emergent project, what is self-organization, why not at the back phenomenon, but it is an emergent property that comes from a complex dynamics among the different elements of a system. So the sense of, what is the sense of uncertainty and unpredictability in these complex systems, because the systems evolve, they have possible bifurcation. So what is the kind of uncertainty and unpredictability there, and the sense of why in the complex systems there is not a linear causality, so one cause that produces one effect, and bigger the cause is bigger is the effect, but there is, so the effect can feed back to the causes, and also that there is this what is the sense of open. So these are the just for example, this is okay. This is a very well-known lab activities, the Bernard cell. We have here oil with some colored pigments in it. That is kept. That is on eaten here. So it is kept in a state that is out of the equilibrium, because there is the energy supplied in ETH mode. Okay. And at the beginning, this system is in a conduction regime, and then after a critical moment, there is a threshold, a critical moment, a convection regime starts. This means that the molecules of the oil starts to move in a circular way here, and they create in the circular way, and this phenomenon is amplified because of the system, And a new order emerges because this pattern emerged. These are called the Bernard cells, because this form of hexagonal cell emerged as a pattern. Okay, so the order emerging from a somehow chaotic regime of the molecules. It is also interesting because here the molecules can decide, have two possibilities: to move clockwise or anti-clockwise. But if some started clockwise, then there is all the system that rearranged accordingly and to create this order. So there is this threshold, but in some moment after this rumor, this noise, there is the system that finds another equilibrium that is very robust, because you can try to break the cells, you can try to that, but they reemerge. So it is a new equilibrium from one state of equilibrium to another state of equilibrium through this process of interaction of the system with the environment, okay, that creates this state. So this is a very simple lab activities. You can see also that you can analyze and you can measure and you recognize correlation between the white of the cell with the come si dice spessore del liquido, with the liquid spessore, with the profundity, the depth of the anyway. So this is a very simple activity, and it is there are many teaching materials to do that, because also it can be realized rather simply in a lab activities, but this was the most important point. What lessons can we take from this simple case? Okay. And this was the epistemological activities that was carried out with the students. Okay. The first one is, what does it mean that this is a complex system? Okay. This becomes an example of it, for example, of what is the relationship between the part and the whole, in the sense that little change, the change of the molecules, can create a big system, a structure in the wall, but also the general structure influence the dynamics of the different molecules. So this is, it creates a new circularity between the part and the wall. And there is this emergent property that is a order, that a pattern that cannot be explained in terms of the property of the single elements. It is much, we say, typically they say that there is a property, the system has properties that are more than the sum of the property of the single system. But also it is interesting because you need, in order to recognize the phenomenon, you need to move from the molecules time scale level to understand to this system level, to much more macroscopic level, and vice versa. So also the time scale relations is very important. Like it is important to see that the instability in this moment, you have one system, then you start eating the oil, you create an instability out of the equilibrium, but this is the source, the moment to have another equilibrium. So it's not just toward a chaos in the sense of to be far another out completely of the equilibrium, but you can find another equilibrium that is robust. Okay, so also this is an interesting metaphor for that. And also the idea that you have, this is also, I can show you it better, but the sense that you have a sense of contingencies. Just because what I was telling before, there is an arbitrarity here, because the system, the molecule could go clockwise or anti-clockwise, okay? So, and this is, it's a contingency that it starts from one side, but as soon as it happens, all the system rearrange in the same way. So this is actually, this was something that was an example of how the property of complex system can be recognized. But it was more than that. This is just embracing complexity. But there was also this kind of analysis of the activity in terms of the epistemic values. What are the epistemic values? What are the values, the qualities that characterize the knowledge. Here, the knowledge is not characterized by deterministic, linear, mechanistic view, because it's not what can describe this process in terms of certainty, ontological stability, the capacity to control completely the nature, and and the belief of the effectiveness of a reductionist hierarchical structure. We don't have here a system that you can organize in terms of reductionist approach. Instead, here, this is a phenomenon that is emblematic of a new way to value the knowledge, scientific knowledge, in terms of systemic thinking, non-linear connection, change, contingency, probabilistic thinking, circular relationship between different dimensions and space-time scales, links between what appear fragmented or separated, because it was really here systemic thinking is important, because the pattern emerge as a collective behavior, not as a sum of the specific property of the single elements. So in this sense, this is a phenomenon that challenges the Laplacian worldview, the deterministic linear Laplacian worldview, and the system and the element are interacting, and the system and the environment are interacting. Okay, and so also in this sense, it is a way also to recognize that in science there is a space of different possibilities. So other way to talk about science, but we are within science. We are not doing other stuff. We are within science, but there is another value, other epistemic values in the sense of qualities to describe the knowledge. And that was also the other important. This was an activity that was the basis to develop what we were talking about, future literacy competencies, because the evolution of the system in terms of moving from one state to another state passed through a bifurcation here that could go in one sense of rotation onto the other direction of rotation. So in this sense, this is a sort of evolution that can give the epistemological basis to think in terms of uncertainty, possibilities, and open futures. And so in this sense, we recognize, we use the analogies between the evolution of this physics system to the open sense of plurality of scenarios that also in science models are built. And this was also something that was very important for the activity, and also because this gave the name to the project, Kairos. Okay, because this analysis of the time structure of the Bénard cell, of this evolution, was also used to give a concrete base, a phenomenological base, to the point that in physics we don't have only the mechanic linear view of time and the time of the clock, that is an external time that used to measure, to quantify, to linearize the event, putting them into a straight line, just in a position that is all the same standardized. But also in science, in physics in particular, there is also the room for internal time. This is a distinction that Prigogine makes, external time and internal time. And Prigogine uses the science of complex system as a field to discuss and to introduce the concept of internal time of the system, because the evolution of complex system is not due to an external clock, but instead it is related to an inner dynamics of the process in open systems like this, interacting with the environment. And also this time is characterized by moment of discontinuity, because there are kairos moments. This is the Greek perception of time, kairos, is where the opportunity emerge, where the moment that can change the evolution of it can create opportunities in the kairos. Kairos is a very nice god in the ancient Greek culture because it was intervenes in order to give opportunities and to break the routine and to break the course of the events. So to recognize here there are discontinuities, that there are unpredictable changes, and that the change in the science of complex system can be used. It can be also not in this case, but it is an important message for the student that in complex system, small changes can also produce big effect. Small causes can produce big effect, and vice versa. Big effect can then be normalized and absorbed in the status quo. And this is also in some sense the science of complex system described a process, a sense of becoming, and include the sense of a plurality of plausible structure, open future. And this also, of course, this is not in the science in this Bernard cell, but this was, however, something that was discussed with the student, and to think in terms of what can be happen in the action, just to complete, I will say why, just to also to think that if you have a plurality, what does it mean to take action, and why this is an analysis, if you notice here, embracing complexity. It is an analysis how to actualize what is a complex system and complex dynamic. The second dimension was values, to try to recognize epistemic values that are there. The third is envisioning futures, to think about this example, to foster, to develop futures literacy. And the last one is action. Why we did this? Because behind this, there is also an attempt that is very European, okay? This is really a framework. It is called Green Comp. This is a report, a political report, produced by under the mandate of the European Commission, and it was built by the JRC, that is the Joint Research Center. This is a research center that tried to implement some mandate from the European Commission. It is a sort of framework that is supposed to orient educational activities in Europe in order to promote sustainable competence. The philosophy behind this is that it's strongly influenced by ecological perspectives, also somehow feminist perspectives, a sense of the plurality and sense of, this is the sense, the language that you can hear also in this report. I'm finishing, just it's the last. And it's interesting because this is not a behavioral document. It's not a framework that tells people how to behave, just with a checklist, but it's a try to convey a different attitude toward nature, toward the relationship between humans and nature, toward the sense of personal, collective, political action. So it wants to try to change the attitude. So the competencies starts mainly with starting from changing the way of thinking, planning, and acting with empathy, responsibility, and care of the planet. You can see here there is this language that is strongly influenced by this. And these are the area of the Green Comp. It is the competence, the sustainability competencies are really organized in terms of what I already introduced. The first one is to try to reshape, to reframe education, starting from a challenge of the values, and to think about what are the sustainable values. So the sustainable values means to reshape also the relationship within the nature, and what does it mean to what is the concept of fairness in a more than human perspectives, just and more than neuron perspectives. The second area is indeed the assumption that the complexity and the paradigm of the complexity is a knowledge, an epistemological knowledge that is more powerful, more suited to develop a systemic and a sustainable way to interact, to see the nature. The third one is future literacy. So within the European document, future literacy now is part of the main competence area because what they say, you cannot become agent. And agent means at political level, at collective level, individual level. You cannot be agent of change if you are not able to see the future, we are not able to manage a systemic thinking, and you don't adhere with sustainable values. So they are all together in order to try to avoid actions that is not epistemologically, ethically, and also imaginatively based. So the ethic part, the scientific part, epistemic part, the imagination part are complete and enrich the sense of action. Action that is supposed to be at individual, collective, and political. This is also important because this is how to, because it is very typical in our school to promote sustainability in terms of individual actions, just how to behave as individual. This is important, but what does it mean to behave as a collective, as a collectivity? What does it mean also to negotiate value, to see, to perceive us as a whole, but also what does it mean to act at the political level? That will be very important also for the seminar of Lorenzo, who will describe how it is difficult to keep all these agent activities together in the imagination. So just very one word about the results. I'm out of, okay. Okay. Just I wanted to see that yesterday we reported some results of essays that we asked the students to write about the future, just asking, imagine the future in 2040, and this is what typically they write in 2040. This is how the students typically think about the future and time in terms of, I leave my apartment at 7:45, very proud of having respected my daily routine. I enter the skyscraper. And this is a time where the time is organizing the activities. After the Kairos project, instead, we asked the students, it was an interdisciplinary activity with the teacher, Italian teacher and the physics teacher. They were guided into this creative writing. So in group, they had to write essays, stories, imagining to be an element of a complex system. And they wrote these essays, and we call them of the physics of cloud. And actually, the time structure of these essays was completely different. Because the time became, again, the time of the events, the time of the relationship, the time of how you connect with the other of your group, but also with the global system and the environmental system. So they were able to talk about time in a relational stance. The time of the clock, also because it was different, the kind of the task, but however, they had a vocabulary to talk about that. So we analyzed the data according to this different codings, the clock, the time of the clock, and the time of the event. And in these, since in the essays without any kind of activities on complex system, the time of the clock was very dominant in the left. Instead, in the essays of after the analysis of the complex system, the time of the event, the time of the experience became dominant. I go quick here just to say that indeed what we are trying to show and to argue that here, thanks to the science of complex system, it was able to recreate a sense of resonance. This is the word of Armut Rosa. We started from Armut Rosa to analyze the society of acceleration in terms of alienation. This is another very important book that is now very popular, very widely discussed in Europe. It is called resonance. That is indeed the attitude that for him is necessary in order to change and to overcome the sense of alienation, discovering a sense of resonance, of empathic connection with the others and with the natural and with the cosmological level. So I wanted to finish with this because I always wanted to finish with this book and with the concept of confluencias, that I think it is very nice as a way to imagine how the multiple perspectives, the multiple narratives, and the possibilities can dance together, independently of the myth of converging into one perspective, but the idea to be able to dance together in this multiple perspective that is finished. Sorry. Thank you very much.
Thank you very much, Olivia, for your speech. We have time for questions now, comments and reflections. Eva?
Hi, Olivia. Thank you for this fascinating talk. And I have one question in two parts, one more epistemological and one more pedagogical. And the first part is, since the beginning of your presentation, I was thinking about Prigogine and dynamical system and no equilibrium thermodynamics and these aspects of science. And just in the end, you mentioned Prigogine, and Henny will, in the part of the talk that we were talking about more science, you mentioned much more quantum mechanics and not this aspect of this kind of science, that uncertainty is part of these two parts of the science, but it's not the same thing. So why you gave much more focus in quantum mechanics than in dynamic system, if it's just by case or there's a reason about it. And the second part is, it's clear that this to take this project as a whole means that you have to work in more than one discipline. Mean that, as you showed, some experience involved a physics teacher and a literature teacher, and to imagine the future is related to a lot of aspects, that it's not only science. But thinking that if I am a high school teacher and I just can do something in my classes in physics, if let's say, just on work at focusing in discussing no equilibrium system in a typical physics class, it would be something that you should consider good. Or maybe if I do like a reductionism, just looking to the problem as a physicist, if that I'm losing something bigger, and maybe it's better not to do that.
Thank you very much for the question. No, actually, it was very a contingency. I in that moment I thought it was more since I knew that I wanted to talk about sense of complexity in describing the Bernard cell. I used the quantum case just to introduce the sense of uncertainty there, but it was just by chance. I think that all of them are very interesting to questioning and to think about the different natures of uncertainty in physics. Lorenzo will talk about that also, because we have epistemic uncertainty, aleatoric uncertainty, but we have also ontological uncertainty in physics. So to recognize the different nature of uncertainty, so uncertainty that becomes because there are some aleatorical aspects in nature. An explosion of a volcanoes is something that we know that we have, but we don't. There is an aleatoric uncertainty, but there is some epistemic uncertainty that derives from the limitation of our models. So this is a kind of uncertainty that we can try to reduce, in some sense, improving our knowledge. This is why they are epistemic. But through the quantum physics, actually, and the uncertainty in principle, we discovered that uncertainty is not epistemic. We can even it's ontological. It's in part. It's part of the phenomenon. So there are conjugate variables that you cannot measure one without having to lose some determinacy in the other variable. So this is part of the theoretical stuff, not a limitation in our measurement tool. So I think in our case, it is very important to recognize and in a complex system, this is very important also because this randomness that entered there has big implication, very important implication in the evolution of complex system because of this amplification phenomena also. So I think that independently in the threat of the tension between certainty and uncertainty, it is something that strongly characterize science, is very interesting because science has been able to elaborate and to how to manage uncertainty. So this is, and it was just by chance. The second question instead, yes, this is exactly the goal of the new project that we have now that is called FyouTURES. This is a teacher academy. So the problem is how to try to think about how these materials, okay, can be made more flexible, more adaptable to many different contexts, but also how to reconceptualize not only what happens in the classes, but also in the relation among the teachers and at institutional level. Because what we are now trying to discover, what we are now to argue is that also because of some European project, we use the European project and European report, like the Green Comp. They are trying to push and to make a pressure to change how our knowledge is organized and how our schools are organized, because typically the disciplines and the knowledge are encapsulated in disciplines, and it is not easy to discuss about interdisciplinary context and how to also to conceptualize the school as an institution where this kind of is. So I think that in any case, the science of complex system is so powerful and so fascinating and so beautiful and so at reach of secondary schools that is a pity to give to end the secondary schools secondary school just thinking that physics is Newtonian and not it is one of the model. I think that this is a cultural message that is important for them, just to make it Newton also something historical and important, but also to see that it's not the only paradigm that exists in science. So I think it is, however, important. But the relationship with other teachers is delicate, but it would be nice because complexity has been an interdisciplinary topics and discussed. But if you're interested, follow FyouTURES, and because we discussed about this institution and teaching aspects of this.
I'm still stuck on the part that you talked about. Oh, okay, very loud. Okay. I'm still stuck on the part in the beginning of your presentation when you said we should start teaching about the future. And I thought I always saw school and university as teaching the past, only the past. I mean, it's about legacy and heritage. The wisdom that we inherited from our ancestors, so we can depart from their wisdom and construct something new. So school is always about the past. And then there is this new idea now. So I'm trying to relate to it and thinking, what are the obstacles and what you presented as some concrete actions are very difficult to be carried out in normal schools or universities, because we have curricular obstacles, we have organizational obstacles, we have disciplines that are separated, and we have a certain amount of content, knowledge that we have to teach. And we would have to collectively discuss a different, I don't know, set of knowledge. How do you see this in university? Do you do this with your physics subjects, or physics 101 or whatever? How do you do that? How do you deal with your colleagues also?
To start, I prefer to talk about nonsense. Physics have a 5 theoretical physics, applied physics, nuclear and subnuclear physics, nanophysics and material physics, and science. Master physics. And there are stuff. One. Theoretical mathematics. Yes. So this is how we manage in our department this to try. It's not easy. It's not easy because but it's not easy because in any academic department there are many different groups with very many different styles, with many different agendas, and different and we fight every time. But in academic sense, in a good sense, if to save the multiplicity and the. This is what happens at university level in my physics department. I don't know if this is was the answer to the question. No. At undergraduate physics, yes. The undergraduate physics, yes. The curriculum is very traditional. Very, very traditional. Mechanics, electromagnetism, relativity, quantum physics, thermodynamics. And at the second year, there are the epistemological crises, and where the students want to complain and to cry and to dispirited because of this organization of the sometimes. But it's very traditional, it's very traditional. It's at the level of master degree that there is the plurality, and where typically the students find their way.
A gente vai terminar por causa que daqui a pouco tem um outro, né? Vamos fazer um break aqui de 10 minutos para quem quiser assistir não é bem uma sequência, tá? É um outro seminário, mas sobre a mesma temática, ainda sobre futuro. Vai ter uma parte mais aplicada, porque ele vai trazer um jogo que foi desenvolvido para trabalhar com questões complexas, talvez vá um pouquinho na direção das duas perguntas que foram feitas, né? E eu aproveito para dizer o seguinte, isso aqui, na verdade, é uma série de pequenos eventos que, juntos para o pessoal da pós-graduação, tá valendo crédito. Mas se alguém mais estiver interessado na temática, amanhã à tarde a gente tem mais um encontro lá no IEA com a professora Olivia, que vai continuar discutindo essas questões, tá? É um projeto muito grande, e lá talvez a gente tenha mais tempo para fazer uma coisa mais interativa. Então, se alguém quiser continuar, amanhã, 2 horas, na sala Alfredo Bose, lá no IEA, a gente continua essa conversa, tá? Então, aqui é quase como se fosse um aperitivo, né? Para quem quiser se aprofundar, quem quiser tomar, né, primeiro contato com o tema. Tá bom? I'd like to thank you very much, Professor Olivia Levrini, for that speech. And we have a break of 10 minutes, and we come back with Lorenzo Miani to the FyouTURES. No, I don't know if it's corrected in English. Okay, 15 minutes. Okay, the time to take a coffee and come back. Yes, okay. of seminars, and I'd like to introduce you Lorenzo Miani. This is a PhD, not a PhD, a postdoctoral student at the group of physics education at the Department of Physics in Bologna, University of Bologna. He was a former PhD student of Professor Olivia. And the most interesting that Lorenzo, in the middle of his, is a part of his PhD, he developed a game that in a sense put out this kind of discussion about the future in a practical application. And the courses have been used in many different sets. Even last years in Brazil, I think we have tried to use the game in a course in, I think, Agatha, that is here, Agatha, yes. And Agatha was with Christina, and maybe during the questions, they can give some, make some comments about. And Lorenzo, we are very happy that you accepted to be with us. In fact, Lorenzo was invited for another meeting last week, but we took the chance that Lorenzo will be here to invite and to arrange to have this talk about the game in the future and the research that he made about this. Okay, thank you very much, Lorenzo, and the talk is yours.
Thank you very much for the introduction. All right. Hello, everybody. My name is Lorenzo, as Mauricio said, and we will spend the next couple of hours talking about this creation, FyouTURES. This game is, we call it a board game for building collective scenarios. It's an activity that blends all the conversation that we had in the last couple of hours. So it's about future, it's about sustainability, it's about climate change, it's about uncertainties. And now we will go deeply in detail of this game. We thought, yesterday we talked about with some of the students that were following the course, we discussed about possible ways of how to organize this session today. And we came out with this idea. So I hope the ones that were not there yesterday will agree. So I will start with the introduction of the game, like of the background of the theory that is behind for the first, I would say, half an hour, 40 minutes. Then we will have the possibility to play the game because we have it right here, even in a small version, but we have it. And also all the other materials are in digital version, so we can access it easily. And then like we will play, I don't know, for half an hour, 40 minutes, depending on what you want to do. And after this, we will discuss together about your thoughts about this activity and the results that we had in our, like this was, as Mauricio said, this was part of my PhD. So all the analysis, all the study that we made on the data collected in this game were part of my PhD thesis and some couple of papers that we published on this. I hope you agree with this schedule. If you don't, raise your hand. But yes, this is our idea. So, okay. As I said, the aims of today are these ones. I will not go through again. So, this game is built around three main concepts. The first one is sustainability. The second one is future. The third one is uncertainty. I will not go through the sustainability one and the future one in detail because Olivia already presented them, so it just would be a repetition. But I want to address like these aspects, the fact that when we talk about the competencies that are needed for what is called sustainable future, we are talking about these words: values, futures, complexity, and action. All these terms are terms that are part of the work that we do, that are part of the research that we're carrying on. So there is a lot of closeness between what is our idea of thinking about a complex future, envisioning a complex future, and what are the guidelines, at least in our environment, is the European environment. Then we can also discuss about the differences between these perspectives and how maybe things are different out of Europe. The main aspect about all these competencies that they are not just a checklist. They're not competencies that are, okay, I will work on competence 1 and competence 7. These are 12 competences all around in 4 different areas that are intertwined, interconnected, and they cannot be taken apart. This is because when we talk about sustainability, and we will see this through the presentation, we need to have a systematic approach, like to look at the system in its own complexity. So this was for sustainability, but as I said, I will not go much in detail because we already talked about it. As for the future part, same discuss. Okay, we use this conceptualization that comes from the future studies field that gives us the possibility to, what we take from this methodology, from this field, is the fact that we can imagine different scenarios with respect to the one that we live already today. Now, again, this was already said, so I will go much in detail. I want just to focus on this aspect that is like a connection between the world of the future studies and the studies on climate change. I don't know how many of you are, I mean, I think all of you know about this. The IPCC entity, the Intergovernmental Panel on Climate Change, they produced this shared socioeconomic pathways some years ago. Already, it's been already 10 years that they are going on. And these are scenarios. These are scenarios in which we try to envision different behaviors of people, different pathways, where we have different type of risks do we have to deal with. So we can talk about challenges for adaptations, challenges for mitigation, or we can talk about our capability of staying in between these challenges and dealing with them. These two things are really, really connected. Because if we think about, for example, the, I don't know, the regional rivalry, that is the SSP3, is a scenario where we have high challenges for adaptation, high challenges for mitigation, mostly because there is no discussion, no connection between different people in the world. We have a scenario, what is called a rocky road, something that would be really difficult to deal with. And this is basically our probable future. That is the type of future that we are currently, the type of life we're currently living right now. But if you think about the preferable one, so a future that we would like to live in, then probably we can impact on the environment, on the planet. So these two concepts are really, really interconnected, and they are part of the game. The third aspect that was basically the main concept around which my thesis revolved is the concept of uncertainty. And the concept of uncertainty is absolutely fundamental for our understanding of the world, for the scientific process itself. The way in which we deal with the uncertainties makes what science is. And I will now go a bit more in depth about this because I really care about this topic and I wanted to talk about it today. So I will start with this. This is an epigram, a Persian epigram coming from many years ago that tells this. I'm not able to read the Arab, but I will read the English one. That says, men are 4 types. And when I say man, of course, it's a person. Man who knows and knows that he knows, so he is a scholar, so follow him. A man who knows, but does not know that he knows, so he is asleep, so wake him up. A man who does not know and knows that he does not know, so he's seeking guidance, is a student, so guide him. But a man who does not know and does not know that he does not know is somebody that you need to be afraid of, so reject him. Why I like to use this? Because this is the exact same type of differentiation between what is known as the known-unknown matrix. It is a type of categorization between the knowledge that we know, the knowledge we don't know. Specifically, we talk about 4 different categories. It is one is the known knowns. These are aspects we are aware and understand. They form the basis of our knowledge and provide solid foundation for decision making. Basically, this is the science we have. This is all the knowledge we study in schools. We know that we know it. Then we have the known unknowns, aspect that we know exist, but we do not fully understand. This is all that gray area that is around our knowledge. For example, when we study the universe, we talk about dark matter, all these type of things. We know there is something, but we don't know it exactly. So this is the space of our personal uncertainty. Then there are unknown knowns, aspects that we do not realize we know. And this is more difficult to deal with, but they are usually buried in our subconscious, overlooked, or dismissed as irrelevant. And discovering these insights can lead to surprising turning points in the decision-making process. It's like the process of becoming aware of what we actually know. And then there is a 4th category, the unknown unknowns. These are things that we do not know that we don't know. Okay, this is like the total void, something that we are not even aware. And they represent the most significant source of uncertainty and risk because they can take us by surprise and derail our plans. Now, this is also called famously as the Rumsfeld matrix. And Rumsfeld was a secretary in the US that basically used this type of reasoning to convince the US to attack Iraq and Afghanistan 20 years ago, using this type of reasoning, saying that they might have nuclear weapons. We don't know if they have them. So to be sure, we will attack them. And this type of reasoning worked. I mean, for them, it was like, we know what happened. So there is a lot, of relevance to this type of reasoning, like the way in which we deal with our uncertainties shapes the society that we have. Now, when we talk about climate change, mostly we can distinguish. So this was like a whole category about knowledge. Now that we go more in detail about the concept of uncertainty, we can distinguish between 3 different types of uncertainty. That is the reflexive one, the epistemic one, and aleatoric one. Now, the aleatoric uncertainty is the uncertainty connected to the inner variability of a system. Specifically, if you talk about climate change, we need to address the fact that climate is a complex system. Therefore, there are inner uncertainties that we cannot delete. They are there, they are part of the system. Therefore, this type of uncertainty cannot be reduced, but it can be quantified through statistics. I don't know when the next earthquake will happen, but I can make a bunch of studies that can tell me the probability of an earthquake happening tomorrow, for example. I cannot base my whole knowledge on this, but informs me. The second type of uncertainty is called epistemic, and this is basically connected to our capability of knowing the reality. So it's our capability of producing models, of making predictions, of understanding what happens around us. And this uncertainty, that is basically the uncertainty that is usually taught in schools, like the error, like you need to reduce this type of mistakes in order to reach the proper measure, like the real measure. Even we don't know if there is a real measure, but. And this depends on our ability, our capability to learn the system, to study the system, to study the reality. The third one, the third type of uncertainty, is connected to the human behavior. It's called reflexive because it has a reflective process, and is the uncertainty that we have on how people will behave in the future and how people will react to the predictions that we have about the future. Think about the COVID pandemics. I know it was a really big problem for all of us, specifically in Brazil. We didn't know how people would have reacted before, We didn't know like the changes that this would have led in our society. Therefore, we couldn't predict what would have happened like in a 2-year span. Nobody knew, because this uncertainty was deeply rooted in the capability of humans on changing their behavior. Okay, how can we talk about this? Through scenarios. We cannot reduce this uncertainty. We don't know how people will actually act in the future, but we can say, okay, what if people will start, to agree all together? They start to have a common plan, What happens if instead people will say, no, everybody cares for their own? So we create these scenarios that are basically the SSP that we described before, ways of dealing with this type of uncertainty. We have a fourth one then, that for physicists is really important. That is the ontologic one. That is the uncertainty connected to the deep reality. It is something that is not just, cannot be studied, but is there. We still don't know how to map it. So there's like an addition to the end. But we know that there's also like this uncertainty. That is the uncertainty we talked about before, is really present in quantum physics and quantum mechanics first. But for now, it's there. And in the climate sciences, we still don't use it. It's a philosophical. Now, these uncertainties can have different roles in our process of learning. These uncertainties can be used as a concept. I go in a class, I talk about this uncertainty, almost like as we're doing right now. Basically, like now you know more about these uncertainties, so they can be considered as a concept. So learning uncertainties. But also uncertainty is not just a concept. It's a way to understand how science works. So like to deal with this process of dealing with the uncertainty. Moreover, if we go over, like if we increase the scale, we can see that learning these uncertainties can help us in developing an uncertainty and probabilistic thinking. So to use this way of dealing with uncertainties to make decisions in our daily life, and last level, to inhabit what can be called risk society. That is basically like one of the ways in which we can describe the society we live in today. And when we learn to deal with these uncertainties, with this manufactured risk, with these wicked problems in the real life, we can actually tell that we know how to deal with this profound uncertainty. Okay. I finished with the scales, with the numbers, like this was now we're talking about more other things. But this was necessary to actually construct a scaffolding to present why we need to unpack the concept of uncertainty in order to understand what are the ways in which you can act on these problems. If we only use the word uncertainty, things are uncertain, we don't know what to do. I know that there is also all the emotional aspects of uncertainties. So for example, how people think about their personal future, like I'm uncertain on what to do, okay? But here we're talking about the scientific uncertainty, not the personal dimension. This reflects on the personal dimension, but I'm not dealing directly with that. Okay, this really nice picture is the graph that I produced to connect all this reasoning, and it's basically the structure that was behind my PhD thesis. You can see you can basically recognize all the different dimensions. You can recognize the futures cone here with all the desirable, blah, blah, blah. Here, the 4 layers of uncertainty that I just described. Before, actually above, the 3 types of uncertainties that work as a lens to understand this reality. And at the same time, a parallel past cone that is basically, that connects all the types of past that we are uncertain about. Because there was an image that we were talking about in these days that connects all the different type of pasts. For example, like I have one past, is my personal past. It is connected to the one of my family, is connected to the one of my region, of my country, of the area where I work on. But this past is a partial one, because there are also all the lost past, the past that were not told, the past that were not recorded. So all these type of things, in the end, led to the specific present that we are living on. And we need to take into account these dimensions in order to have to be aware about the complexity of our reality. Okay, all of this to this. That is the futures game. I will not explain in detail this in some minutes. This game was created 2 years ago, in the end of 2023, as an emerging property of a course that we created with Francesco as part of our PhD. And it's an interesting, complex object, quite difficult to deal with at first, but I will try to do my best to explain it right now in the short. So the main aim of the game is to, there are several. Sweating a lot because it's quite hot. Reasoning with and making decisions with a powerful simulation tool, giving meaning to data, making decisions with different types of uncertainties, building future scenarios grounded on real data, and develop system thinking and decision-making competence. So there are several data, they span different dimensions. Okay. Now, the first main aspect of this game is the simulator. This game is based on the use of a simulator. It's called En-ROADS, was produced by the MIT and a collaboration of different partners. We didn't make the game. I want to be clear on this. We did the simulator. And the simulator uses different categories that you can work on to create possible scenarios. Or in another way, to make a prediction of what could happen if you reduce or amplify a specific dimension. These dimensions are mostly connected to energy. We start from the conventional sources of energy, emission control, green areas, energy efficiency, electrification, and green energies. All dimensions connected to the way in which we produce, we conduct our life today. And as you can see here, there are some numbers and also some graphs. These are tools that project what could happen from today until 2100. This is an important number, 2100, so 75 years from today, based on the type of actions that we could do. I will explain in detail like how this works, but the simulator is a complex simulator. There are guidelines that can tell you exactly how it was built on the type of data he relies on. But as you can see here, all these dimensions are interconnected and form what we can actually call a complex system. You can see there are feedbacks, there are points where all different dimensions converge and then reemerge. Like all these categories show us that it's not just a linear process. It's not like we move one sector and we have one change. If we move 3 in a different way, in a different moment, we can have different type of results. Therefore, we can consider this a complex system. As you can see, there are a lot of graphs. In this simulator, there is a lot of information that is difficult to deal with. This is an example, like pressing on the top of the simulator, you can see all these graphs here connected to sources of primary energy, cost of electricity, sea level rise, like many, many dimensions that then can change depending on the actions. So you see the difference between the type of future that is the probable one and the type of future that might be the desirable one. So therefore, the black one is always the probable, that is the scenario that says what could happen if we keep things like right now, you know, like the so-called business as usual, even though business as usual doesn't mean anything, but this is the concept. And then the light blue one show us what actually could change, what could differ if we do some certain actions in a certain moment. Now, how do we interact with this simulator for the game? We created a grid that basically divides each of the sectors. Okay, each of these sectors in a discrete quantity. So for example, this whole sector is divided in 5 parts. And if I want to move the slider, I can move it of 1, I can move it of 2, I can move it of 3, up to 5. And for each of these moves, there is a specific number that needs to be inserted into the simulator that basically gives you the specific quantity that allows you to move of 1, of 2, or 3. Why we have to quantify this? Because of course, if you give you the simulator and I tell you build the scenario that you would like to live in, you just put all the sectors to the maximum, easy. But when we have to contextualize this type of activity in reality, we have to deal with the economic part. We cannot forget about that. We know that the system we live in is not the system we would like to live in, but still, this is the world we live in. So we need to understand how it works. Therefore, we created a budget that gives you the possibility to make moves. The budget is divided into 2 parts. There is a budget that is fixed. Like the game plays in 3 turns, I'll explain this lately, but in each turn gives you a specific amount of money. We can consider this as the standard taxation. So like money that the government takes directly from like the normal business as usual scenario. And then there is another part of budget that can be taken by taxing some specific sectors. For example, if I want to reduce the production of energy from coal, I will tax the coal industry. I will take money from that taxation that I can then use to invest, for example, in the renewable sector. These movements create a second budget that can be also used to make moves. A third aspect. So we talk about the predictions, we talk about the different dynamics. What about uncertainties? I talked a lot about uncertainties. How can we actually put the uncertainties into the game? Now, the simulator, although it's complex, gives only one result, gives only one number, one type of graph that shows the type of differences that we can have. Therefore, we thought about introducing another layer that is made of these wildcards. These wildcards need to be drawn at the start of each round and gives you a context, gives you some sort of reality check. Basically, for example, let's take this one called Eureka. In this Eureka, there is a big discovery that allows people to use cold nuclear fusion, therefore having a new source of electricity, of energy, without CO2 production. This, as you can see, they are categorized between different types of uncertainty, because this type of event is deeply connected to our capability of producing more science. So it connects to our capability of understanding the nature. But there are also others. For example, there is a big fire that destroys part of the Amazon forest. There is a big flood that prevents the capability of producing electricity with water industry. Hydroelectric energy. But also uncertainties connected to the ways of people behaving. For example, there is this one that I really like, that is the Go Vegan. So in this case, like a big movement of people decides to stop eating products derived from animals. In this case, the production of CO2 diminishes a lot, because of course, like there is a big change in how people deal with the animals in general. And that each of these events are then connected to a specific action that you have to do in the game. So basically, for example, if you take the fake plastic, it says, a new technology has been developed that produces a synthetic material with the same characteristics as plastic, but much less polluting, thus decreasing the use of oil. Therefore, you decrease the production of oil, and increasing the efficiency of homes and industries, because then it's less expensive to do something. So then in the simulator, you move up one notch. All right. Now that I presented all of this big mess, I will give you the possibility to explore directly this game. We have here the boards. Usually this game is played in 6 people. Usually it has 3 rounds, but today we will only do one small round. So no division between 2030, 2050, 2100, but just directly to 2100. To build a desirable scenario that follows the Paris Agreement. That is like the kind of milestone we're still working with, even though we know that it's quite old right now, but it's still some sort of landmark. Now, the aim is to put global warming under 1.5 with respect to pre-industrial times. Therefore, the numbers that you can see in the simulator should be less than 1.5. That is the goal. To do that, you have to use the En-ROAD simulator to, of course, check all the dimensions and to use the wildcards. These are the 3 elements that we need. Now, we only printed the boards because all the other materials are accessible in a digital version. On the left, you will find the rule book that is all I said explained better in a PDF. On the right, you can find the web tool to play with the wildcards. I will just give you some seconds now, but I want to explain how the wildcards app works. So I'll just go back to it, no worries. You will find a page like this if you open the wildcard, but you will do it later, where basically it asks you first to shuffle the deck. So you have to press that button. And then you press reveal round 1, reveal round 2, reveal round 3. These type of buttons will open you the possibility to deal with the wildcards. And then the third step is you press on each of them, and they appear in their magnificency, giving you the description and the effect. This was one way we thought about giving these wildcards in a setting like this. Okay, so I leave this here. It's 4:50. I think we can play for at least half an hour to see how things go. Usually we play in groups of 6, but in this case, it's not mandatory. We have, I think, 6 pieces of paper. Yep. So I don't know, also groups of 2 or 3 can be okay. If you don't want to play, it's also good. I mean, you can take a half an hour break and just explore whatever. But yeah, these are here and 1 sheet per group, exactly. So I don't know how you want to divide, just do it yourself. As they say, you are all teachers or kinda, so you know how to create groups. Wow. Yep. Okay. Okay. All right. So we can do two things now. Either we collect our thoughts now, and then I present you the results that we already had in our implementations, or I present you the results, and then we have a final conversation all together. What do you suggest? What do you think? The second one? Do you agree with the second one? Like first I present my results, and then we have a general conversation? Okay. All right. So how did we approach the analysis? Hey. Okay, sorry. So how did we approach the analysis of the data? And first of all, what type of data we had to deal with? So basically, when we did this implementation, we had around 30 students, so 5 groups of people playing. During a course that was kind of 20 hours, this was made at the end of the course. We gave them some questionnaires at the start of the course and at the end of the course, same questionnaires connecting on sustainability competencies, the one that we've seen before from Greencom, to see the perspective on this. Also, we recorded the intervention made during the lessons and during the gameplay, and the transcripts, transcripts of some interviews that we made with a part of the students of the course, specifically 9 of them, that lasted between 1 and 2 hours. Each interview was either 1 or 1 hour and a half, in which we went through all the course and all the game. All the analysis was made on using like a thematic analysis to see what type of themes were actually emerging from the data. And then there were like many steps of confrontation and validation, double-blind coding process, all of the things. This is one of the things that we created at the end. What is this? It's basically a representation of all the interview. Each white line or gray line is one line of the interview. And the colored line are the moments in which these students talked about a specific theme. And these themes are image of science and climate, the sustainability dimension, decision-making and relation between science and politics, and agency and what we call reality shock. Basically, we call this spectra. It's like the distribution of the interview and when the students talked about something. Then we did a second layer of this data. Okay. Inside this colored line, we could distinguish between a before and after. So before the course or the game, after the game. We did this following the sentences that the students were saying. And mostly, for example, like we will go in detail later, but for example, like in this case, this is the green one. So we talk about sustainability, and we can distinguish between a naive approach and a balance between sustainability dimensions. So the students were saying, for example, yeah, before the course, I thought that the environmental dimension was the most important one. And after the game, I realized that also dealing with the economic aspects or the policy aspects was actually something necessary to build a desirable scenario for everybody. So this is the way in which we represented the data. But what were the results? Okay, so what happened? Let's say during the play, mostly, well, like it was making the count this morning with Agatha of how many times we had the implementation of the game. Up to today, I would say 6 or 7, even though there was very small. Usually, this is what happens. Like this happened between students, teachers, researchers, professors, environmentalists, people who don't care at all. All of them kind of react in the same way to the game. So they start with their aim for a desirable future, okay? Like all of us have an aim of a desirable future, okay. They start to interact with the game. So the interaction is between players, between the wildcards, with the simulator. There are many factors happening all at once. They are asked to achieve a specific objective. So for example, in this case, the Paris Agreement, we had different implementations also with different type of objectives. And this is a reiterable cycle because like they start to interact informed by this objective. What happens is that at one point, some processes start to manifest. These processes are connected to linearization, optimization, and simplification of the complexity of the issue, mainly because they want to achieve the results and they forget that they are thinking about creating a desirable scenario. So what happens is that all of them, every time, they develop a dystopian scenario, a future where they don't want to live in. And they don't recognize this. This is important. They don't recognize that they are building this type of dystopian scenario. Once we tell them, but would you like to live? Then I will tell why it is a dystopian scenario. But when we ask them, would you live in this type of future? All of them say, oh, no. Or better, some of them say, yes, if I had the money to live in that future. And I will now tell you why in detail. Therefore, this creates a contradiction, and Cristiano entered in the specific moment for the contradictions that we called a reality shock. The moment in which the type of image that you have of reality collapses with a real reality, even though we're talking about a simulator. But there is this process in which you thought that, okay, I will just raise all the taxes. Have you seen in the simulator now, of course, if you tax some of the specific like coal, oil, carbon, you can see that the predicted value goes down. But specifically, if we go back to the, now that you know the simulator, you will understand this better. If we go back to this, look, here I just try to create some sort of possible scenario, okay? If we look at the temperature change, we can see that we can actually stay inside one of the limits that were asked by the global community. When you think about the price of energy, for example, we can see that the cost doubles. And we can see that the cost of electricity has a spike, a huge spike in the matter of 10 years. Now, who can afford a future like this? Who can actually live? What is the real cost of these movements? Like, okay, the prices will be higher, but who's going to pay? You know? And students started to realize and started to say, all right, but I don't want to be there. You know, I don't want to live in that future. It's not the future that represents me. Therefore, okay, this picture I will tell about later. What happened is that all of them, in the end, created the SSP4, the one called inequality, or a road divided between people that can afford a mitigation. In this case, yeah, there are small challenges for mitigation, you know, because like you implement things that are really expensive, but basically you forget a part of the world or a part of your society. And what they did was they isolated the different dimensions of the problem regarding the choices effect, and they started to favor cause-oriented strategies that prioritized problem mitigation while undermining socioeconomic implications. Okay? They were not focusing on who was going to pay the price. They were only focused on the value, the number. Okay? And therefore, they created dystopian scenarios in which temperature goals were quickly met at the expense of socioeconomic inequalities. We can see some of the sentences of these students. For example, some of them said, it's a dystopian world. It would be utopian if everyone could live in this world. But at the same time, it's very nice. Emissions are low, electrification everywhere, a lot of reforestation. Others said, what I think about the world we built was that it was somewhat unfair world. The problem of pollution was practically solved, but at the expense of values, at the expense of certain human rights. Because some of the groups, because like this is a simulation of a decision making, a policy making. So also we asked them what type of political system they implemented. It was a full democratic, if it was like they have to take into account the decisions of people, how people would react, the reflexive uncertainty, or if it was just, like, yeah, we'll do this and people will just adapt. A group, specifically this group here, implemented a dictatorship for kind of 70 years. At the end, they were super happy, about the results, because they said, yeah, but our aim is the environmental one. So for their environmental goal, we reached the goal. And we asked, okay, but what about those 70 years in between? Oh yeah, there were like, some sort of crisis, like people were not actually happy. The cost of electricity, like, tripled. But at the end, we reached the goal. And, we were like, okay, what kind of sustainability is this, And specifically, later, I think. Yes. Like, when we talk about sustainability, usually we divide between the pillars. So the economic, the social, and the environmental. And only if you take into account all of these dimensions, you can have what can be called systemic sustainability. If you only focus on one aspect, then all the social economic side, for example, will go wherever they want. Now, yeah, to go back here, I talked about the reality shock, that is this discrepancy, but also at the same time, the game helped in complexifying the perception of reality. Therefore, also students, and we're talking about students between 17 and 18 years old from high school that decided to come to our university, they started to change their perspective on politicians. Specifically, they started to say, okay, before the game, like if we go to the graph, back and forth, yeah, like this orange color, all this was between ingenuity about the science politics link, generally a mistrust of the process, and an awareness of the decision-making process. So they started to say, okay, before the game, I thought that politicians just didn't care. They just didn't want to, they have a specific agenda to destroy the planet. Now, I'm not saying that politicians are like absolutely aware of the problems and they have like the goodwill, but I realize that this is a complex issue and not so easy to act on it. Therefore, I'm starting to change my mind, also like to listen to the causes of these, politicians when they talk about these issues. And usually when we do this course, it's always around the COP. This year is in Belém. It was like something between a disaster and I don't know, like this year was really bad because like many people didn't want to go. There were like a lot of protests. But usually like students change the way in which they react to the information about this policy making. Okay. Another dimension, an interesting dimension connected to this, is that once they become aware of the complexity of the issue, they realize, or at least we realized, that we can describe a type of hope that they can have around the future that we can call harmful hope. That is a hope that can create problems, dangers, harm. When two things happen. When starting from a good driver, like a hope for a better world, we apply processes such as unpacking the complexity of the issue and linearizing these complex and interconnected aspects. Therefore, when we do this, we reach what can be called harmful hope. And if we are able to identify these harmful hopes, that usually is connected to the capability of, the incapability of applying a systemic approach to a complex issue, then we can work on that. Okay, and I think that, yeah, these are like some of the results that we gained from the game, like what we were able to record, where basically students became more aware of the problem. and they started to realize that certain things have to be done in a way that is not easy, or not only from the ethical side. Usually, like we see that the game help participants in appreciate the complexity of policy negotiation. To then, like, it underscored the necessity of considering, of course, both social and environmental justice, not just working for the environment per se. To explore the impacts of climate policies, all the things that you already talked about. But this, and we talk about also this harmful loop. Therefore, with respect to this, we want to, like, one of the aim would be, in order to have what is called meaningful education, to have an informed, active hope. So a hope that is not just based on the personal belief, but an hope that is based on the proper knowledge of the complexity of the. In the last point, like, this game is made not to give you a solution, not to present a path to reach, I don't know, like a desirable scenario, but to perceive the complexity of the problem, to complexify. And also, like, of course, it needs to be addressed that the simulator is based on a certain type of economy, a certain type of system. So it's not that that's the only type of future. That's a representation of the limits of our present, and it must be accounted in. Okay, so, like, we, as I said, published some of this in different chapters. We focused on, like, following the different levels. Like, we know that there is a reasoning on different types of uncertainty that helped students in changing the perspective of what science is and how science works. Another work, this is like already published, is accessible, it was published in. Students realize the perspective-taking process concerning the difficulty of making and taking decisions in situations marked by high uncertainty, and created scenario is intrinsically an uncertain process. But also they realize the mature attitude towards sustainability and scenario making, accepting and involving different typologies of uncertainty. Okay, that said, I would like now open the confrontation. I have like something to say at the end, but I would like to hear from you now. Just before this, I inform you that we are building a newsletter for the game. So if some of you are interested in either following like the possible new steps of the game, so like all the things that will happen maybe in the future, or to be part of this, like possibly we were talking like with Mauricio before, Agatha this morning, like to make different implementations in different contexts, or also like to readapt the game for the local context. That would be really nice. So if you want to stay in touch, just scan the QR code, put the email, and we will send the newsletter soon. Okay, I will stop talking now. Questions, considerations? What do you think about this? I really would like to listen to you now.
Hey, congrats for your presentation. It was a very interesting game. I don't know if I lost this point during your analysis, but how exactly do you think that the students understood the uncertainty? Because during your presentation about the framework, you described so many different uncertainty, and they are quite hard to understand for students. And also, another point, it's because maybe the simulator can have like an hidden learning that we can forecast the future, and the simulator is very precise way to I think it. I don't know. My experience teaching about the uncertainty, it's not quite easy to to do. So I would like to know about this.
Thank you for the question. The game was played at the end of a course, as I said, of like 5 lessons before this. Each lesson was 3 hours, and each lesson focused on how uncertainty shapes science. So the students arrived usually to the game when we do it in the full version. Students arrive to the game with all the knowledge regarding the typologies of uncertainty. So we start from the uncertainty in physics, then we move to the uncertainties in climate change, the connection between the decision-making process, the role of future, so the difficulty, the uncertainty in creating the scenarios, then uncertainty in dealing with the scenarios in policymaking. These are all the steps. In the game, we know that the simulator has a lot of pros and a lot of cons. All the pros are connected to the capability of replicating the at some level the complexity of the reality. It gives a lot of information about all the implications. Like there are, I would say, at least 100 or 200 graphs that can be explored in order to read all the different dimensions and how they can impact. So it is super rich. At the same time, it linearizes the process. You can see one line reaching the future. So basically, it's almost as if there is only that future. Like if I do A, I will receive B. That's a problem of the simulator. Therefore, we added the wildcards to shake this, to give students some sort of aspect that cannot control and they have to deal with. So that was our idea of making them deal with the uncertainty of the scenario. Then, at what level they actually understood this? From the interviews, we could tell that the epistemic uncertainty is always the one that is easier to grab. Aleatoric one is also like kind of understandable, but it needs probably a higher level of mathematics to actually understand, for example, what is a complex system that usually is not taught in schools, at least in Italy. And the reflexive part, in another work that we did, it's something that it's either fully accepted or rejected. Sometimes people say, no, but science doesn't have to do with people. Science, is like there, it's like something higher than our living. Therefore, like I have one quote that I always remember from one student, that when she had to deal with the reflexive uncertainty, she said, no, but science makes like a lot of experiments, mainly because we want to take out the people, of the problem, so that we can have like the pure concept. But when we talk about, I mean, you can do that if you want to throw a ball on the ground, that works perfectly. But if you want to talk about climate change, you have to put that inside. And of course, it's a difficult process. I don't know. That's how we dealt with like making all the cores and trying to shape the game in a way that fits. We would like to build our own simulator. I always say this, that introduces all our understanding of uncertainty in order to change the, but it takes a lot of time and money. Let's see. Yes.
Okay. So I want to talk about another game that I played when I was younger. That's called Plague Inc. I don't know if you know it, but it have like this kind of vibe, but it's a more sadistic game. You are a virus or a bacteria, and your goal is to kill all of humanity. And you select points to evolve. And sometimes the game will tell you like a random mutation happened, and now you can spread around in birds. I don't know. And the game brings that kind of with this random new feature you now have. And I was thinking about that game, and I want to ask you if you do have like the intention to digitalize this kind of game, because I think in a digital form you could be more technical with some aspects that happen behind the scenes for the students to use it, or I don't know, like any player using it. And yeah, that's it. I could imagine like a SimCity game, like a city you can simulate and choose which kind of energy you are building, or how do you structure the city if you are going to invest in public transportation or stuff like that. So if you
Thank you. I was talking about Plague Inc. some days ago, I think in the conference, and it's really interesting because it's the last time I downloaded the game, it was just the start of the Corona pandemic, and I felt guilty in playing the game, so I just deleted as soon as it started. So there are many aspects to respond to this question. The first one is that the randomicity of the mutation that in Plague Inc. is basically connected to the wildcard. Is it the same level of, okay, this happens, you have to deal with it? So in that sense, there is this kind of connection. For the digital version, we tried to make a digital version in the Ezera conference. I think Gabriel was there, yes. It ended up being really technical and not as beautiful as the this like shape, because this shape connects the futures cone. It has different dimensions, all connected. It gives also an imaginative layer. The type of digital version we managed to do was an Excel sheet, and it doesn't work. I mean, it's good, okay, but it doesn't work. So it would be nice to implement that. On the fact that you could simulate a city, I was talking with this today with Agatha. The problem is that the simulator works on a global level. So it takes all the information from the globe and makes averages. Because, I mean, if you realize like the simulator is super powerful because it gives you exact values like in a matter of seconds. To do that, you need to simplify a lot. Therefore, it works on global averages. Therefore, it doesn't give the possibility to make local predictions. Or at least there are some variables that are local, like the sea level rise or the temperature change area by area, but they are kind of fixed. So in the moment in which you create one city that you want to simulate, you need either to say, okay, this city represents the world, or you have to lose the connection between the global values and the local applications. Now, what is best to do? To keep a global simulator that is simplified, but at the same time gives you the complexity of the dimension, or to have something that is just local, more radicated into reality, but doesn't give you the capability of seeing the big picture. One can choose. It depends on the context, it depends on the people you're working with. You can do double versions. You can make, I don't know, like the simulation we were talking about before, like for the forest or for a specific country. But then when we talk about the climate change, we know that the country that produces the most are the one better equipped to resist to like the sea level rise or the temperature, with respect to the others that were not part of the problem are already suffering. So does it make sense to focus only on one country when we know that the problem is shared? I don't know how to answer these questions. I know how to pose them. I don't know how to answer them. But yeah, thank you. Okay.
Another one? You'll be okay. I said that you have the chance to make two. Okay.
I was thinking about I will need some time to structure the question, but about the simplification you try to make with the idea of the game. So you looked at this, oh, you need to put some money on this kind of energy, and what does this imply in other kind of energies, for example. But doesn't the structure of the game, of the simulator specifically, induce induces a simplified vision of some stuff. Like it's just a slider in my screen that I can just, I don't know, eliminate COO uses, for example. And how would you deal with this kind of simplified imagination of over the power you just like can rule the world any way you like and don't deal with the consequences immediately, because the simulator is simplified, as you said, and it doesn't show you the consequences objectively.
So this is another important question. The simulator, as we noticed from the results, is complex enough to sparkle the imagination about the issue. So it is a certain good level of complexity to show you the problems of society. Ciao Mauricio, ciao. But to also not having to deal with all the different dimensions that are huge. So it's like it tries to be a middle way between these two aspects. All the dimensions that are not directly presented by the simulator are then part of a second part, like the aftermath of the game, in which usually in different versions, we ask the students to elaborate on the scenario. So the first time we elaborated the scenarios they produced through the interviews. So we sit there, we started to talk about it, and then slowly it emerged all of these dimensions. The second time we asked them to write some sort of reports in which they were trying to describe how the world was changing depending on the actions they were making. But this was also not working much. We are now producing a third version that will be applied in January and February, in which we follow 3 steps, in which first we will ask them to just create some sort of narration about all the actions they did, just one-to-one, like, okay, I did this, then I did that, then I did that. On a second level, there would be the critical analysis of this, trying to see where like the process went wrong, for example, or which were the specific moments in which things changed. And a third step in which they create the new scenarios, in which they start to answer the questions, what if I act this way? What if I change this variable? What if I actually put not just the value of the temperature as a goal, but for example, the number of people dying for heat waves? Also, that's one of the graphs. We try to amend the lags of the simulator through all the activities that we do around it, but it takes time. One of the problems, people say, oh, can I do this in 1 hour? Can I do this out of the course? Can I do this at night to make it fun? You can, but to deal with complex issues, you need time. And I think that's one of the things that is required from this game to actually present you the reality. Okay. Oh.
Well, good afternoon, everybody. First, I'd like to thank you for the presentation. I really enjoy the aspects of your research. I don't know if you say that and I didn't get it, but I'd like to ask you, because you said that in the final, for example, in an interview, you're trying to analyze the epistemological practices and the concepts of them. But did you considering the idea of to do the analysis during the mediation process and the dialogue between them? Because actually, maybe you could receive different data in the 2 scenarios. So that's the question, actually. Yeah, not in interview in the final of the process, but during the board, the play. Yes.
We thought about it, and we realized that it's kind of difficult to have people stay in the game and outside of the game. Like to have this meta-reflective process is not so easy. And also it's difficult when you have a class of, I don't know, like 30 people to make this cooperative version, because like all together, all the groups together, so that you can actually have a moment in which you analyze what's happening. We thought about it. We talked with a game designer on how to do it, but usually they were saying like, yeah, you should add a competitive layer, like a way for them, they have to reach a specific goal altogether, and then you confront it. The problem is that I don't like the competition. I don't think it's a way of dealing with these issues, because it's a cooperative game. Nobody wins, nobody loses. It's a moment of like meta reflection altogether. So I think about it. To make the analysis of the scenarios during, it would be the goal of our activity. So to create a tool simple enough that gives you like, I don't know, 2 questions, 3 questions, can actually make you reason about the word you're creating. That would be the ideal, but
So I think it's time to say thank you. And everyone, you are welcome to come tomorrow to EAA and continue to discuss with Olivia, not with Lorenzo, I think.
tomorrow there is like this overposition of things. I'm leaving tomorrow. I'm going back to Italy tomorrow night. But okay. I would like to, like, there is this opportunity for, it's not mandatory at all, but I will explain what it means this now. But at 1 p.m., so like the seminar of Olivia starts from 2, as you know, but at 1 p.m., I will make a presentation of a project that I wrote that connects Brazil, Chile, and Italy. That would be basically is my application for a postdoc. It's a project I wrote. I will make that presentation to the Italian research group, and I will stay here in the university in the same room where you have the seminar in the afternoon. So this project is called FyouTURES, and the acronym stands for Embracing Uncertainties to Open Possibilities for Intercultural Approaches in Science Education. Something that I worked a lot in the summer. I applied. I'm still waiting for the results. So I don't know if this is gone or will not go. We'll still see. But I would like to profit from this opportunity that I'm here to listen from people that lives another reality with respect to mine. That's just, to have a confrontation. So you're not obliged at all to participate, but the room will be the Bolsi area, Alfredo Bolsi, in the EAL at 1 p.m. If somebody wants to join, you are more than welcome. The presentation will be half an hour, and then there's going to be space for conversation. And then you have the proper time to prepare for the justice. That's it. Thank you all.